Section 3.4, PointSlope Form. Now, this is the second form that we're talking about. Slope-intercept form, y equals mx plus b. In 3.4, you have another form that you have to memorize. PointSlope form. Now, when you start thinking about these, they're really not too bad because they tell you what you need to know. So what does PointSlope form tell you? It tells you the point and slope of something. Slope-intercept form tells you the slope and the intercept. So it tells you right in the title what you're using or what it tells you. So we're going to start with PointSlope form. We're on page 195. Look under the essential understanding. You can use the slope of a line and any point on the line to write and graph an equation of the line. Any two equations for the same line are equivalent. So there's your key concept. Look over your key concept. It says the point-slope form of an equation of a non-vertical line. It's important to understand that we don't have a slope that's undefined, which is a vertical line. So we can't have a vertical line. So if you know the slope m that goes through a point, now you will notice that it says x sub 1 and y sub 1. That just means any point. So we have a point and we have a slope. Here's your equation. Y minus y1 equals m times the quantity x minus x sub 1. Now, it says this in the key concept, but this is your y coordinate that goes here. The m is your slope, and the x coordinate goes here. So all you do is you plug things in. Now, if you look at the bottom where it says, here's why it works, this is actually something really cool. It actually goes over the definition. And so it tells you the definition of this. So we know that the slope equals y minus y1 over x minus x1. So all we're going to do is we're going to multiply both sides by the denominator. The opposite of dividing by all of this is multiplying by all of this. So watch what happens. These cancel. You're left with y minus y1 equals m times x minus x sub 1, which is the same thing as point-slope form. So let's do some examples using it. Problem 1 on page 196. Writing an equation in point-slope form. So point-slope form, once again we have a point and a slope. So under the got it problem, we have 8 negative 4, that's our point, and our slope of 2/3. All we do is plug stuff in to write an equation. So y minus y sub 1 equals m times x minus x sub 1. So here's my x. I'm going to plug it in right here. Here's my y. I plug it in right here. My slope plugs in right there. So I get y. Now here's the kicker. This is the only part that's difficult. What's y? Y is negative 4. You're plugging it into a negative. So a negative 4 is going to turn into a positive 4. Equals m, which is 2/3, times x minus 8. That's it. You are done. You just wrote an equation in point-slope form. Now, if you actually wanted to write this and go further, you could distribute the 2/3 and then subtract the 4 and then put it in slope-intercept form. But we don't need to do that because it didn't ask us to. So we have an equation written in point-slope form. So now let's do practice A, problem 1. The point is 4, 2. The slope is negative 5/3. So let's plug it in. Y minus your y value on your coordinate, which is 2, equals m, which is our slope, negative 5/3, times, in parentheses, x minus our x value, which is 4. And there's your equation. Y minus 2 equals negative 5/3 times the quantity x minus 4. The second thing you're going to learn how to do is how to graph using point-slope form. So let's look at the got it problem. We have an equation of y plus 7 equals negative 4/5 times x minus 4. So let's first find the slope. What's your slope? Our slope is negative 4/5. Now your points. This can get a little tricky, but it's pretty easy, but you got to be careful of these two values. This is obviously your x value, and this is your y. However, remember your formula is x minus whatever your x value is. So here it's just 4. So your x value is 4. But here it was y minus and then something. So what would you plug in here for the value of y sub 1 that would give you a plus 7? It'd be a negative 7. So your point is 4, negative 7. So here's how you graph it. You graph the point. That's all you do. So let's graph the point 4, negative 7. So I'm going to count by, I'll count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And once again, you can count by twos if you want. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. So we're going to first graph our point, 4, negative 7. 4, negative 7 would be right here. Now our slope is negative 4/5, so that means we go down 4, 1, 2, 3, 4, over 5. 1, 2, 3, 5, 3, 4, 5. So right here. So our point, we have a point here, and there's our line. Negative 4/5 is our slope, and 4, negative 7 is a point that the line goes through. Now once again, since you are using graph paper, your graph is going to be more accurate, and you should be using a ruler or straight edge to also draw your lines. Let's do number 3 on the top of page 197. What would your slope be? Negative 1. Now if we write that as a fraction, it'd be negative 1 over 1. What's your point? Since this is x minus 2, or x minus x sub 1, this would have to be a negative 2. It's the opposite. Here it says plus 5, so that means it has to be a negative 5. Because once again, if you're getting confused by this, remember this is your formula. So this, x minus, what would this have to be to make this a plus 5? This would have to be a negative 5. What would x sub 1 have to be to make this a plus 2? It'd have to be a negative 2. And that's how you get these. So we graph the point negative 2, negative 5. Negative 2, negative 5. 1, 2, 3, 4, 5. We're out of room here. So negative 2, negative 5. And our slope is negative 1 over 1. So negative 1 means we go down 1 to the right 1. Down 1 to the right 1. Now you notice I ran out of room on my graph. So you could go the opposite way. Up 1 to the left 1. Up 1 to the left 1. Now you may say, well, wait a minute. How can that be right because you're going the opposite way? Up 1 would be positive 1. Over negative 1 left would be 1 over negative 1. No matter either way you get it, you're going to get a slope of negative 1. It's the same thing. So here is your line. The next part is writing an equation given 2 points. Now you could be given 2 points or 2 points on a line. Either way would work. So let's turn to page 198. We're going to do numbers 5 and 6. Number 5. Now if you look at the graph, all you have to do is determine any 2 points on that line. Now you'll notice they actually gave the points to you, but they don't always have to do that. You may have to come up with your own points sometime. So what are the 2 points on number 5? Well, we have, it looks like -3, 4. And it looks like we have 1, 1. So let's think about this. Why do we use point-slope form? Point-slope form means we have a point and the slope. Well, I only have a point. I don't have the slope. So what you have to do is get a slope. So let's get a slope. Subtract your y's. Divided by subtracting your x's. That would give me 4 minus 1, which is 3. And -3 minus 1 is -4, so we get a slope of -3/4. So now, pick a point, either one. Now you may say, Mr. Humphreys, I don't get this. How can you pick a point when they're 2 different points? Well, I'm going to show you what happens here. So let's start with -3/4. So this is your x, this is your y. So your point slope form would be y minus 4 equals m, which is your slope, times x minus -3, which would become x plus 3. Now let's say you picked 1, 1 instead. You would have this as your equation. And you may say, well, wait a minute, I have 2 different equations. How in the world can I have 2 equations that represent the same thing? Watch what's going to happen. I'm going to distribute this. Now you don't have to do this. If it told you to solve the equation for y, then you'd have to do this. But I'm going to distribute the -3/4. That gives me -3/4 x minus, that'd be 9/4. Then I'm going to add 4. Y equals, now let's see, -9/4. That's really -2 and 1/4. -2 and 1/4 plus 4. If I subtracted, all you're doing is taking 4 minus 2, which is 2, and then minus another 4th. So that would be -1 and 3/4. Or, I'm sorry, 1 and 3/4. So we get -3/4 x plus 1 and 3/4. Okay, over here, let's distribute the -3/4. Y minus 1 equals -3/4 x plus 3/4. I add 1 on both sides. Y equals -3/4 x plus 1 and 3/4. Look at what I have. Now, by the way, what kind of form are these in? These are in slope-intercept form. And they're both the same. So look at your graph. Does your graph go from one point to the other in number 5? Does it go down 3 over 4? It does. And where does it look like it crosses the graph? At a y-intercept of 1 and 3/4. So this also works. Number 6. Identify the 2 points. The points are, let's see, -1, -2, -3, -1, and 1, 2. So I have to first find my slope, subtract my y's over subtracting my x's. That gives me -3 over -4, which gives me a slope of 3/4. So my slope is 3/4. So I'm going to write an equation. Y minus, I'm just going to use this one. That one looks easier. Y minus 2 equals 3/4 times x minus 1. There's one equation. Or you could do y plus 1 equals 3/4 times x plus 3. And that's if you used this first point. So either one of these would be an acceptable answer. The last problem we're going to do is problem 4. Problem 4, using a table to write an equation. So we're under the got it, part A. It says, the table shows the number of gallons of water, Y, in a tank after X hours. The relationship is linear. What is the equation in point-slope form that models the data? So, don't confuse yourself here. Remember, this is exactly the same as number 5 and 6, except now they put it in table form instead of a graph, and they put it in context. They actually give it some meaning. So I'm just going to recopy it real fast. Now it says it's linear, so we don't have to worry about that. But what are the two things I need to write an equation? Point and slope, or slope and intercept. Now here I don't know slope and intercept, but I do have points. Here's a point, 3,320. Here's a point. Here's a point. Here's a point. Pick any one of them. So here I'm going to pick the first two. I'm going to pick these two right here. Here's my 2 points. Find the slope. Subtract your y's. So that'd be 4,570 minus 3,320 over your x's, 3 minus 2. So 4,570 minus 3,320, that gives us 1,250. So my slope is 1,250 over 1. So now use point-slope form. Pick any point you want. I'm just going to pick the first one. Y minus y, which is 3,320, equals my slope times x minus 2. Now whenever you write a function, whenever you write an equation, I really want you to solve this and get it solved for y. Please solve it for y. So I would get y minus 3,320 equals 1,250x minus 2,500. I add 3,320 to both sides. I get y equals 1,250x plus 820. So there is my equation. So what is the equation in point-slope form that models the data? Well, in point-slope form, your answer would be this. Or you could use any one of these points, it doesn't matter. But I want you to solve them for y, so that would be my answer as well. What does the slope represent? Well, my slope is 1,250. What does that mean? X represents time in hours, and waters per gallon is y. So remember, this is y, this is x. So your slope means 1,250 gallons per hour. So it's 1,250 gallons per hour is the volume of water in the tank.